Hello and welcome to the second episode of Space Future, a channel dedicated to talking about the future of humans in space. Today's episode we're talking all about the question, how will we be travelling in space and where will we go? In November 2016, Professor Stephen Hawking warned, "I don't think we will survive another 1,000 years without escaping our fragile planet." The renowned theoretical physicist believed life on Earth is at an ever-increasing risk of being wiped out by a disaster, such as a sudden nuclear war, a genetically engineered virus, or the rising threat of artificial intelligence. He urged people to take more interest in space travel and said we must continue to go into space for the future of humanity. However, it's important to note that the space travel industry has split into two areas of development now: the space tourism industry and the new space industry. The space tourism industry focuses on stratospheric joyrides, all the hype surrounding Virgin Galactic and Blue Origin. Then there's a new space industry, the various aerospace enterprises with ambitions of establishing moon colonies and terraforming Mars. Elon Musk and SpaceX, for example. This space tourism industry shows the next 5 to 10 year window of the future of space. As commercial space flights become more readily available, it is believed that the cost of these flights will dramatically decrease over time. A ride on Virgin Galactic costs $250,000, while a trip on the one-passenger Lynx currently sells for $150,000. One of the biggest recent innovations that has aided in lowering the cost was the creation of reusable rockets that can return to Earth without frying upon re-entry. SpaceX intends to send an astronaut to the space station for $20 million versus the $70 million charged by Russia for a seat on a Soyuz rocket. The hope is that space missions will eventually be launched for around $200,000, a dramatic decrease. This industry is set to become the new way in which we travel and experience our Earth in the future. But what about beyond that? Michio Kaku is one of the most recognizable faces of science, with several best-selling books and numerous television appearances, including on the Discovery Channel and the BBC. In his book, The Future of Humanity, he argues passionately that, like Hawking, that our future lies not on Earth, but in the stars. Kaku says, "The stars are extremely far away, but one day we hope to use advanced physics to go faster than the speed of light, warp drive. Until we get warp drive, we're stuck with rockets that are below the speed of light, and the planets we've discovered that are Earth-like would take hundreds of years to reach. This means we have to find the secret of extending the human lifespan or learn how to freeze ourselves." Science fiction has always talked into how we might perceive our possible futures and make them into realities, as the future is now. When we look into films in particular, we can see new possibilities that are based on current truths and future possibilities. 3 movies in particular to answer both the how and why questions include Interstellar, Passengers, and WALL-E, and The Martian. The movie Interstellar uses the idea of black hole travelling. While there is plausible possibilities of this being a possibility, we would have to travel extreme distances to find one, and so it's more likely that we would need to invent ways of travelling faster and further while also preserving the human body to either live longer or be frozen and thawed upon arrival. Rather than speeding through wormholes, theoretical tunnels that provide shortcuts through space and time, to hop from planet to planet like the astronauts do in the 2014 film Interstellar, the sleeping astronauts aboard the spaceship Avalon in Passengers are travelling at 1/2 the speed of light. They're on a 120-year journey to an Earth-like planet called Homestead 2 that's located in a neighbouring star system. It's impossible to build spaceships that fast with today's technology, but the idea is more practical than the wormhole voyages depicted in Interstellar. While scientists have yet to find evidence that such tunnels exist, travelling at a fraction of the speed of light is physically possible, at least theoretically. But humanity has a long way to go before spacecraft will be able to travel as fast as 1/2 light speed. Light travels at over 1 billion kilometers per hour. The fastest machine humans have ever built was NASA's Juno spacecraft, and its top speed hit about 265,000 kilometers per hour, relative to Earth. But where will we go? NASA announced that its next mission is to land man on Mars. However, Mars is a whole different story to that of the moon landing in the 1960s. It takes 9 months just to get to Mars, then you have to wait a few months for the planet to realign, and then another 9 months to come back. So it's a 2-year journey where weightlessness, cosmic radiation, and micrometeorites will all be problems. Mars is also frozen, so we're going to have to heat up the surface, which is called terraforming. Early settlers who came to the US almost 400 years ago had game to shoot, plans to raise, and topsoil on which to grow crops. But we will have to bring everything to Mars ourselves. That's why cost is so important and why we have and want robots to build things. We're going to need genetically engineered crops to thrive in that environment and nanotechnology to create lightweight, super strong building materials that are prefabricated to create domed cities. Mars is a very likely possibility when considering the next 10 or 20 years, however. We've also discovered 4,000 planets so far in the galaxy, and we know that on average every star in the galaxy has a planet of some kind. There are many planets in the entire universe, but as far as we know, there is only a handful which can possibly support life. Space scientists and astronomers continuously scour the vastness of space for finding signs of life elsewhere in the solar system and even outside of it. Now, taking one celestial body at a time and devoting all your time and resources to ascertain whether it supports life would be too imprudent and wasteful. That's why astronomers look to certain pointers in a celestial body and then determine if it has the potential to support life, or in other words, whether it's habitable. So what are the requirements for a planet to support life? These factors include it has to be a comfortable distance away from a star. The stars around it have to be stable. It should not have a very low mass. It must rotate on its axis and revolve. It must have a molten core, and it should hold an atmosphere. In the recent years, there have been a great deal of talk about finding liquid water on Mars and the possibility of life existing on the red planet. All this coverage has resulted in a lot of questions being raised for people always staring out into space, including a few interesting ones. For example, is the existence of water and the only condition that needs to be present on a planet in order to host life? To better answer that question, let's look at the various factors that make a planet habitable. As of now, we do not have any concrete proof of the existence of life anywhere else in the universe. Therefore, in order to establish the criteria of habitability of a planet or a natural satellite, the conditions that support life on Earth also need to be extrapolated for other celestial objects. In other words, since we haven't found proof of life anywhere else, the basic conditions that support life on Earth can be taken as a benchmark for the sustenance of life on any planet. There are a number of conditions that a celestial body must fulfill in order to support life. These conditions involve certain geochemical, astrophysical, astrological, and geophysical criteria. According to NASA, for a celestial body to sustain life, there should be extended regions of liquid water, conditions favorable for the assembly of complex organic molecules, and energy sources to sustain metabolism. Engaging the habitability of a planet, a number of factors must be considered, including the planet's bulk composition, orbital properties, atmosphere, and potential chemical interactions. There will need to be a balance of gaining technology talked about earlier and finding a planet with the habitable conditions that will allow us to determine what the future of the how and the where of space future will look like. Thanks for watching.